Now, first, let's quickly review what we studied in Chapter 3. If you're trying to find the relationship between two variables, and I'll just take a quick example so it's easy for us to understand. Let's just say the number of hours that you spent studying for your final exam and your score out of 100, right? So these are the two variables. Now, it's pretty clear that your score on your final exam depends on the number of hours you put into studying for the exam. Okay, so the number of hours of study is the explanatory variable. Since the score depends on X, which is the number of hours of study, the score on your final exam is the response variable or the dependent variable. So if we want to investigate the relationship between these two, we can make a good assumption that as the number of hours increases, the score on the final exam should also increase. But if we want to be sure what this relationship looks like, we first collect data, maybe from a large class. The next step is construct a scatter plot. That's always the first thing to do. We construct a scatter plot. It really doesn't matter which way it goes, at least up to this point, but let's just put the explanatory variable on the x-axis and the response variable, which is your score, on the y-axis. Now, the reason why we make a scatter plot is to see if there is a pattern. When you look at these crosses, okay, these are points, data collected from a large class. Okay, and there are definitely more points, but I'm just giving you an example here. So clearly these points are forming a clear linear pattern. Okay, so we would call this a linear pattern. So what is the form? It's like the shape of the pattern that's forming. And if the pattern that's forming is a straight line, we call it a linear form, L-I-N-E-A-R. Now, the direction can be positive or negative depending on the relationship. Okay, so if it is this example we are looking at, number of hours of study and then the score on the final exam, clearly this relationship is positive, or at least we can expect it to be positive. As the number of hours of study increases, the score on the exam also increases. It is possible that certain relationships are negative, so that's the direction. When I say direction, it's positive or negative. So in this case, in the first case, a positive relationship is as x increases, y increases. In the second case, as x increases, y decreases. This is a negative relationship. Once that is determined, we look at the strength from the graph. What is the strength of the relationships? So by looking at the graph, we can kind of make that sort of decision based on the graph. But remember that the graphs can be deceptive. If you change the scale of the graph, the relationship might appear to be stronger than it really is or weaker than it really is. So we can say something about strength, but that's not the final word. So the next step is, in this class at least, we are only going to look at linear functions. If it is linear, then the next step is to calculate correlation R. So unless it is linear, we do not calculate R. So it's appropriate to calculate R only if the function is linear. A correlation is a number between -1 and 1. We've seen this in the previous class. And for a negative relationship, correlation lies between -1 and 0. And for a positive relationship, the correlation lies between 0 and 1. The closer it is to 1, the stronger is the relationship. The closer it is to 0, the weaker is the relationship. Now, finally, we look at the line that best fits the data. We're only looking at linear patterns here. So that's why I'm saying it's a line, only because it's linear functions or patterns that we are looking at. If we see a linear pattern, then the next step is to calculate the equation of the line that best fits the data in the scatter plot. So we don't really have to worry about how it's calculated. Just use software or use your calculator to figure out the line, equation of the line, and that will be in the form y equals a plus bx. And we've seen that b is the slope, a is the intercept. It doesn't matter what letters we use to denote the slope and the intercept, but it's in the form y equals mx plus b. So in chapter 4, we are looking at the regression equation, y equals mx plus b. And what do we do with this equation? Once we get this equation, we can make predictions. Within the range of values of data collected, we can make predictions. We can plug in an x and figure out a y. And when we plug in an x to figure out a y using this equation, then the y that we get, which is our response variable, is called the predicted value. So that's what we're going to do in chapter 4. Find the equation of the regression line that best fits the data set, and then use the equation of the line to make predictions of y given x. So we plug in an x to get a y. That's all there is to it. So remember that the predictions, you can plug in any number you want in for x, but the predictions are good only within the range of values of data collected. And look for the predictions can only be valid or reliable only within the range of values of the x of the data that we collect.